Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation 2 Component 2 paper from autumn 2022. This paper is worth 120 marks in total, and this is the fourth video of 6. It will focus on questions 13 to 16, which account for 16 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 13. Hubert plays a game. He spins these two fair spinners. So it's important to know that these spinners are fair. So we've got spinner 1 and spinner 2. Hubert calculates the score. He squares the number on spinner 1 and then multiplies it by the number on spinner 2. Part A, complete the table below to show all the possible scores. Okay, so he squares the number on spinner 1 and then multiplies it by the number on spinner 2. So let's fill in this box here. So the number on spinner 1 is 2 and the number on spinner 2 is 1. So he's going to do 2 squared and then he's going to multiply it by spinner 2. So he's going to multiply that by 1, which gives us 4. Okay, we've dealt with that now. So we're going to do this column here. So spinner 1 is 3. He squares spinner 1 and then he multiplies it by spinner 2. So that's 2. That becomes 18. And then we're going to do this box here. So the value on spinner 1 is 2. The value on spinner 2 is 2. So he squares spinner 1 and multiplies it by spinner 2. So that gives us 8. And then here he squares spinner 1 and multiplies it by spinner 2. We're going to do the same here. So we're back up at the top. So it's 3 and 3. So squares spinner 1, multiplies it by spinner 2. And then we've moved down to the 2 here. So he squares spinner 1, multiplies it by spinner 2. And then down here, he squares spinner 1, multiplies it by spinner 2. And then we're down at this column. So he squares spinner 1, multiplies it by spinner 2. So spinner 2's now got a value of 4. So that's 36. Squares spinner 1, multiplies it by spinner 2. So now we've completed all of those values. Part B. To win the game, Hubert must score more than 9. He plays the game 108 times. How many times would you expect him to win? So if he plays the game 108 times, we need to find the probability that he wins, and then we can use that with the number of times he plays the game to see how many times we'd expect him to win. So he wins if he scores more than 9. So let's have a look in here at the numbers that are more than 9. We're not going to include 9 because it's more than 9. So 18, 27, 36 and 12 and 16. Don't forget 16, you might not have filled that in, but it's definitely a value in that table. So we have 1, 2, 3, 4, 5 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So he's got a 5 out of 12 chance. So if he plays 108 times, we can multiply that probability by the number of times he plays. So 5 out of 12 as a fraction. Arrow out from your fraction, guys, and then multiply by 108. So that tells us that we'd expect him to win 45 times. Question 14. Linda cycles 31.5 kilometres from home to work each day. Part A. One day her journey to work takes her 1 hour and 45 minutes. Calculate her average speed in kilometres per hour. So you might recognise the speed, distance, time triangle. You may work with that. So we've been given our distance, we've been given our time, and we're calculating speed. So speed is the distance divided by the time. So distance divided by time. So we know our distance is 31.5 kilometres. We've got our time as 1 hour and 45 minutes. Now, when we're calculating with time, we need it as a decimal, guys. So we're going to have to convert 1 hour 45 minutes into a decimal. So we have 1 hour, and that 45 minutes is 45 out of 60 minutes, because there's 60 minutes in an hour. So that's 3/4, so that's 0.75. So we have 1 hour plus 0.75. So we have 1.75 hours. It's important that we don't write 1.45, guys. That's what a lot of people do. We've got to convert it to a decimal. And then we're going to carry out this calculation. So 31.5 divided by 1.75 is equal to 18. Okay, so she travels 18 kilometers per hour. Part B. Linda cycles home following the same route. She leaves work at 4 p.m. Her average speed on this journey is 15 kilometers per hour. What time does Lydia arrive home? You must show all your working out. Okay, so we have speed. We have our distance. It's the same journey. Okay, so we're still working with this triangle, but we're working out time because we want to know what time she arrives home. So we're going to have to work with the fact that she left at 4, but we don't know how long it took her. So we have speed, we have distance, we're working with time. So time is equal to distance divided by speed. Okay, so we know our distance is 31.5. We know our speed is 15. So 31.5 divided by 15 is 2.1 hours. Now we don't know what 2.1 hours is in terms of hours and minutes. It's definitely 2 hours because we've got that 2 in the whole number part. But what's 0.1? So 0.1 times 60 tells us that that's 6 minutes. So it takes 2 hours and 6 minutes to get home. She leaves at 4 p.m. So 4 p.m. add 2 hours would take us to 6 p.m. and then add those 6 minutes would take us to 6:06 p.m. You can write it like that with p.m. or you can write it in 24-hour clock. It doesn't matter which. Question 15. Find the value of x and the value of y. So we're working with parallel lines here. Remember, these arrows indicate that these two lines are parallel, and both of these parallel lines have these transversal lines that cut through them. So we're working with the angle facts for angles in parallel lines. So let's look at x first. So here we have 3x. We're trying to find the value of 1x. So the first thing we need to identify is if we have any corresponding alternate co-interior angles that we can work with. So these are the two parallel lines, and what I'm just going to indicate here for you is this F shape, okay? So these are the two parallel lines. This tells us on this F shape that these two angles here are corresponding. If they're corresponding angles, okay, so I'm going to write that there. If they're corresponding angles, they are equal to each other, okay? And they're corresponding because they're on the same side of each parallel line, on the same side of this line that cuts the transversal, and then on the same side of each parallel line. So 3x must be equal to 126. So to solve for x, 3 multiplied by x, the opposite of multiplying by x is to divide, multiplying by 3 is to divide by 3. 3x divided by 3 is x. Do the same on the other side to balance it. 126 divided by 3 is 42. So straight away we can say that x is 42 degrees. Dealing with y now. So looking at this side here, we have 2y here. Now what we ideally would want is an angle here, they are corresponding, or an angle here, they are alternate. So we can find one of those two angles, and I'm going to find this angle here because this is a straight line. So 180 subtract 152, angles on a straight line, add to 180 is 28. So this angle here is 28 degrees. Now we're going to draw another thing on here. So this is our parallel line. This is our parallel line, and then down here, so that Z shape that identifies alternate angles. So angles that are on alternate sides of the transversal that cuts these two parallel lines. So these angles are equal. So these are alternate angles and they are equal. Sometimes exams ask you to write reasons. They haven't asked for reasons here. I'm just writing this here for your notes. So 2y must equal 28. So 2y equals 28. So same again, we're going to solve for y. 2y is 2 times y. I want it to be y equals. I want to isolate y. The opposite of multiplying by 2 is dividing by 2. So 2y divided by 2 is y. Do the same on the other side to balance the equation. 28 divided by 2 is 14. So y is 14 degrees. Question 16. Calculate the value of this sum and give your answer correct to 1 decimal place. So we're going to enter this into our calculator, guys. That's on a calculator paper. But I need to enter in it exactly as it is there. So the first button I'm going to press is the fraction button because everything's in a fraction. On the top of my fraction, I've then got this square root. And inside the square root, I've got 1,456. Now I'm going to move to the bottom of the fraction. So I'm going to arrow down. So I've got 1.3 cubed. So 1.3 cubed. And then we are subtracting 0.7. So subtract 0.7. Double check that it matches exactly as it is on the paper there. No need to arrow off this time because we've got nothing else to enter. We're just going to press equals. So to start with, I'm going to write all of this down on my piece of paper. It's a 2-mark question. So this, enter correctly into my calculator, is going to get me 1 mark. And then the last step is to round to 1 decimal place. So 1 decimal place is 1 place value column after the decimal point. So this is what we're interested in, but we have to check the next number. If it's 5 or above, it makes this place value column go up by 1. So 25.489, etc. becomes 25.5 to 1 decimal place.